Tonight we're going to do something special. We're going to slow down, look up, and explore the most peaceful secrets of the night sky. Not the loud science, not the overwhelming numbers, just the gentle, calming mysteries that hover above us every single night. So before we begin, if you're enjoying this journey, feel free to like the video and subscribe, but only if it genuinely resonates with you, and let me know in the comments where you're watching from tonight and what time it is where you are. I always love seeing our little community gathered from all corners of the globe. Now find your most comfortable position, dim the lights, maybe turn on a soft fan for that gentle white noise, let your breathing slow, and together let's drift into tonight's peaceful exploration of the cosmos above. The night sky has been humanity's oldest companion. Long before screens and streetlights, before clocks and calendars, people looked up at the darkness and found wonder. They found stories. They found peace. And tonight, you're going to rediscover that same ancient connection. The sky hasn't changed. The stars are still there, patiently waiting. And the secrets they hold are gentler than you might think. They're not harsh or complicated. They're simply there, quietly existing, ready to ease your mind into rest. When you look up at the night sky from a dark place, away from city lights, you're not just seeing stars, you're witnessing something profound. You're looking at time itself frozen in light. You're seeing across distances so vast that your mind can barely hold them. And yet, somehow, it all feels intimate, personal, as if the universe arranged this display just for you, just for this moment. Every photon that enters your eye has travelled unimaginable distances to arrive at precisely this instant. That's not chaos. That's connection. The darkness of the night sky is not emptiness. It's fullness. It's potential. It's the canvas upon which the universe paints its most delicate artwork. And we're about to explore every brushstroke together. There's no rush, no urgency, just a slow, meandering journey through the peaceful corners of the cosmos. The secrets aren't loud. They don't demand your attention. They simply whisper, and tonight we're going to listen. The night has always been a place of questions. Where do we come from? What's out there beyond our small world? Are we alone? But tonight we're not seeking answers with anxiety or desperation. We're approaching these questions with curiosity and calm. Because the night sky doesn't require understanding. It only asks that you look, that you notice, that you breathe, and that you let go of everything except this present moment beneath the stars. Throughout history, sailors used stars to navigate. Farmers used them to plant crops. Lovers gazed at them in silence. The stars were there for all of it. Every human moment, every triumph, every heartbreak happened beneath the same celestial canopy. You can see tonight. You're connected to every person who ever looked up and wondered. That's a comforting thought. You're never truly alone when you're beneath the same sky that's witnessed all of human history. And here's something beautiful. The night sky changes so slowly that the constellations you see tonight are the same ones ancient civilizations saw thousands of years ago. The stars are patient. They don't hurry. They simply shine. And in a world that constantly rushes, that's remarkably soothing. The sky's a reminder that not everything has to move fast. Not everything has to change. Some things just are, and that's enough. So as we begin this journey, let your shoulders relax. Let your jaw unclench. Let your breathing deepen. We're going to explore the night sky the way it deserves to be explored. Slowly, gently, with wonder, and with peace. There are no tests, no memorization required. Just stories and science woven together into something soft and restful. The kind of knowledge that settles into your mind like a lullaby. The kind that helps you drift away into the deepest, most peaceful sleep. The universe is enormous beyond comprehension, but somehow, when you look up at the stars, it doesn't feel frightening. It feels like home, like you're seeing old friends, familiar patterns in an infinite expanse, and tonight, those patterns are going to guide you into rest. So let's begin our journey together. starting with the very first secret of the night sky, the ancient, patient journey of starlight itself. When you look up at a star tonight, you're not seeing it as it is right now, you're seeing it as it was, because light, for all its speed, still takes time to travel, and the stars are so impossibly far away that their light journeys for years, sometimes centuries, sometimes millennia, before finally reaching your eyes. This single fact transforms stargazing into time travel. The night sky is a window into the past, and that past is vast and beautiful. Let's start with something simple and grounding. The speed of light is approximately 186,000 miles per second. That's fast, almost incomprehensibly fast. At that speed, light could circle the Earth more than 7 times in a single second. But space is so vast that even this incredible speed becomes almost leisurely when measured against cosmic distances. Light from the sun takes a little over 8 minutes to reach Earth, which means when you see the sun, you're seeing it as it was 8 minutes ago. A gentle time delay built into the very fabric of reality. Now imagine looking at the stars. The closest star system to our sun is called Alpha Centauri. It's actually a group of stars bound together by gravity, and the nearest of these stars, Proxima Centauri, sits about 4.2 light years away. A light year is the distance light travels in 1 year. It's a measurement of distance, not time, though the name confuses that. 1 light year equals roughly 6 trillion miles, so when you see Proxima Centauri, you're seeing light that left that star 4 years and 2 months ago. You're literally looking 4 years into the past, but that's just our nearest stellar neighbour. Look at Sirius, the brightest star in our night sky, part of the constellation Canis Major, the Great Dog. Sirius shines brilliantly, and its light has travelled approximately 9 years to reach your eyes. Think about where you were 9 years ago, what you were doing, who you were. That's when the light you're seeing right now left Sirius and began its journey through the void, travelling alone through the darkness until this very moment when it arrives at your eye. Or consider Polaris, the North Star, that faithful guiding light that's helped countless travellers find their way. Polaris sits about 433 light years away. When you look at Polaris tonight, you're seeing light that left that star in the late 1500s. The light you're seeing began its journey around the time William Shakespeare was writing his plays, before the Pilgrims landed at Plymouth Rock, before Galileo looked through a telescope. That light has been travelling, patient and steady, all this time, and tonight it reaches you. Some stars visible to the naked eye are even farther. Deneb, a supergiant star in the constellation Cygnus the Swan, blazes in the summer sky. It's approximately 2,600 light years away. The light you see from Deneb tonight left that star around the time of ancient Rome, before Christianity spread across Europe, before the fall of the Western Roman Empire. That photon has crossed the galaxy, moving at the speed of light for over 2.5 millennia, and tonight, after all that time, it completes its journey by touching your retina. This creates something profound. When you look up at the night sky, you're not seeing a single moment in time. You're seeing layers upon layers of history. Each star is showing you a different era. The sky's a temporal collage, a living museum of light from across the ages. Some of those stars you're seeing may not even exist anymore. They may have exhausted their fuel and died long ago, but their light continues its journey. Ghost light from dead stars, still beautiful, still reaching us across the gulf of space. The journey of a photon is remarkable. Inside the sun, photons are created through nuclear fusion in the core. Hydrogen atoms smashed together under immense pressure and temperature, forming helium and releasing tremendous energy in the form of gamma-ray photons. But these photons don't immediately leave the sun. The interior of the sun is dense with plasma, and these photons bounce around, absorbed and re-emitted countless times. A single photon might take between 10,000 to 170,000 years just to reach the sun's surface, bouncing randomly through the dense solar interior. Scientists call this a random walk. By the time A photon emerges from the sun's surface. It has transformed from a high-energy gamma ray into visible light, and then, finally, it's free. It streams away from the sun at light speed, crossing the 93 million miles to Earth in just over 8 minutes. But that photon you see has actually been on a journey much longer than 8 minutes. It's ancient by the time it reaches you. And here's something even more beautiful. From the photon's perspective, the journey is instantaneous. According to Einstein's theory of relativity, time dilates as you approach the speed of light. At the speed of light, time essentially stops. So from the photon's point of view, no time passes at all. It's emitted and absorbed in the same instant. The photon doesn't experience the long journey, only we do. Only we perceive the vast distances and the passage of years. The photon itself exists in a timeless state, a perpetual now. Think about that tonight as you drift towards sleep. The light touching your eyelids right now, whether from the stars or from a nightlight, has journeyed through time and space to reach you, and yet, in its own frame of reference, it experiences no journey at all. It simply is, present and eternal. There's something deeply calming about that. The universe operates on scales both unimaginably vast and mysteriously intimate at the same time. When you understand that starlight is ancient, stargazing becomes meditation. You're not just looking at dots of light. You're connecting with history, with time itself. You're seeing photons that were already on their way to you before you were born, before your parents were born, before entire civilizations rose and fell. And they arrive now, in this quiet moment, to meet your eyes, to connect with you. There's no rush to this process. The stars have been shining for billions of years. They'll continue shining long after you're gone. They're patient. They can wait. And tonight, they're waiting for you to simply notice them, to acknowledge their long journey, to receive their ancient light. As you settle deeper into your bed, imagine those photons. Imagine them streaming toward Earth through the vast emptiness of space. Silent, invisible, just pure energy moving forward at cosmic speed, through clouds of interstellar dust, past other stars, through the cold void, until finally they reach Earth's atmosphere, pass through the air and land gently on your upturned face, or your eye, or the roof of your house, each one completing a journey millions or billions of years in the making, and you were here to witness it. How extraordinary is that? The distances involved are so vast that our minds can barely hold them. But that's okay. You don't have to understand it fully, you just have to feel it. Feel the weight of time pressing gently on your consciousness. Feel the patient, eternal nature of the cosmos. Let it remind you that your worries, your stresses, your anxieties are small in comparison, not insignificant, not meaningless, just small, just temporary. The stars have been here through everything, and they'll continue long after your troubles have passed. Let that thought comfort you tonight. Now imagine the night sky filled with these ancient messengers. Hundreds of them visible to the naked eye if you're in a dark place. Thousands if you include the faint ones. Billions if you count the glow of the Milky Way, which is made of stars too distant and faint to see individually, but which blend together into that soft, luminous band. Each point of light is a time capsule, a message from the past, and the message is simple. We're here. We're still shining. And we're connected to you across the vastness of space and time. Every single star you see has its own unique journey, its own distance, its own story written in light. Consider Vega, the bright blue-white star in the constellation Lyra. Vega sits approximately 25 light-years away. The light you see from Vega tonight began its journey in the year 2000. It left Vega around the time of the dot-com bubble, when the internet was young, when smartphones didn't exist yet. That photon travelled through the void, never slowing, never stopping, moving at 186,000 miles every single second, for 25 years, and tonight it completes its journey by entering your eye. Think about Arcturus, the orange giant in Bhutas, 37 light-years distant, its light left in the late 1980s. The Berlin Wall was still standing when these photons began their journey. The Soviet Union still existed. The world was different. But the light kept travelling, patient and steady, crossing the vast gulf between stars, crossing regions of space so empty that if you compressed all the matter in a typical cubic light-year of interstellar space, you'd have less than a thimbleful of atoms. Space is not just big, it's nearly empty, and yet light crosses it. Light perseveres. Altair, in the constellation Aquila the Eagle, is about 17 light-years away. Its light shows you Altair as it was in 2008. The financial crisis was unfolding. Barack Obama was elected president. You might have been in a completely different place in your life. But the light didn't care about any of that. It just moved forward. 186,000 miles per second. Every second. For 17 years. Through the cold vacuum of space. Through clouds of interstellar dust that dimmed it slightly but couldn't stop it. Through the gravitational fields of other stars that bent its path infinitesimally. Through it all, the photon travelled, carrying with it information about Altair, information about its temperature, its composition, its motion, all encoded in the wavelength and energy of that single photon. And here's something even more beautiful. The stars themselves are moving. The entire galaxy is rotating. The Sun is orbiting the galactic centre at about 500,000 miles per hour. That sounds fast, but the galaxy is so enormous that it takes 230 million years to complete one orbit. The stars around us are all moving too, each in their own path. Some are moving toward us, some away. Over thousands of years, the constellations slowly change shape. The Big Dipper looked different when the pyramids were built and will look different thousands of years from now. The stars are drifting through space like ships on an ocean, each following its own course. But these changes are so gradual that in a human lifetime, they are imperceptible. The stars seem fixed, eternal, unchanging, and that constancy is deeply comforting. As you close your eyes tonight, you can carry this knowledge with you into sleep. The stars are doing their patient work above you. They're shining. They're sending their light across impossible distances, and some of that light will reach Earth tomorrow, and the next day, and the day after. An endless stream of ancient photons arriving constantly, reminding us that the universe is both incomprehensibly large and intimately connected. You're part of that connection. You're made of stardust, as Carl Sagan famously said. The atoms in your body were forged in the hearts of stars billions of years ago, then scattered into space when those stars died, eventually coalescing into planets and eventually into you. You're not separate from the stars, you're made of them. You're a way for the universe to know itself, and tonight you're resting beneath the gentle light of your cosmic family. The process of stellar evolution is written in the stars you see tonight. Young stars burn hot and blue. Middle-aged stars like our sun glow yellow. Old stars cool and redden. Eventually stars die. Small stars fade slowly, puffing off their outer layers to create planetary nebulae, leaving behind white dwarf cores that cool over billions of years. Massive stars explode as supernovae, briefly outshining entire galaxies, then collapse into neutron stars or black holes, and in death they seed the galaxy with heavy elements. The carbon in your cells, the calcium in your bones, the iron in your blood, all were forged in stellar cores or in supernova explosions. You're made of recycled star stuff, and when you look at the stars you're looking at your cosmic ancestors, the furnaces that created the elements that would eventually become you. That's not poetry, that's literal truth, and it's breathtaking. Let that thought settle into your mind as you drift towards sleep. You're safe, you're connected, and the stars are watching over you, just as they always have. Their ancient light touches you now, as it has touched every human who ever lived. You're part of an unbroken chain stretching back through all of history. and that's a peaceful thought to carry into dreams. The stars ask nothing of you. They don't need your attention or your understanding. They simply exist, shining steadily, offering their light to anyone who looks up. And tonight, that includes you. Receive their gift. Let their patient, ancient presence calm your mind. Let the knowledge that you're connected to them through physics, through chemistry, through the very atoms of your being, ease you into peaceful rest. The stars have been waiting billions of years to share their light with you, and tonight they succeed. The night sky is filled with patterns. Human beings have always been pattern seekers. It's in our nature. We look at clouds and see shapes. We look at wood grain and see faces. And when we look at the stars, scattered seemingly at random across the darkness, we see pictures. We see stories. We see constellations. These aren't just random asterisms, they're humanity's oldest artworks, the very first stories ever told, and they're still being told tonight, in the same sky, with the same stars. Constellations are groups of stars that appear to form patterns when viewed from Earth. But here's the secret. The stars in a constellation aren't actually near each other. They're scattered throughout three-dimensional space, sometimes hundreds of light years apart. But from our vantage point on Earth, they appear to line up. It's a matter of perspective, a cosmic coincidence that creates meaning from chaos. And humans have been finding meaning in these patterns for as long as we've existed. Every culture on Earth has looked up and seen different pictures in the stars. The ancient Greeks saw gods and heroes. The Chinese saw imperial palaces and celestial bureaucrats. Aboriginal Australians saw the dark spaces between stars, creating patterns from the voids rather than the lights. Native Americans saw animals and spirits. Each culture projected their hopes, fears and stories onto the canvas of the night sky. And those stories have been passed down through generations, surviving longer than empires, longer than languages, longer than almost anything else humanity has created. Let's explore some of the most famous constellations, the ones you can still see tonight if you look up. We'll start with Orion the Hunter, perhaps the most recognizable constellation in the entire sky. Orion is visible from almost everywhere on Earth, and its distinctive shape makes it easy to spot. Look for 3 bright stars in a row. That's Orion's belt. These 3 stars, Alnitak, Alnilam and Mintaka, are some of the most famous stars in the sky. Even though most people don't know their individual names, they just know the belt. According to Greek mythology, Orion was a great hunter, the son of Poseidon, god of the sea. He was tall, strong and handsome, but he was also arrogant. He boasted that he could kill every animal on Earth. This angered Gaia, the Earth goddess, who sent a scorpion to kill him. The scorpion stung Orion, and he died. Zeus, taking pity on the hunter, placed him in the stars. But he also placed the scorpion there as the constellation Scorpius. And here's the beautiful part. Orion and Scorpius are on opposite sides of the sky. When Orion rises in the east, Scorpius sets in the west. They never appear in the sky at the same time. Even in death, even in the stars, Orion is running from the scorpion that killed him. The chase continues forever, told every night by the wheeling stars. Above Orion's belt you'll find his shoulders. The star Betelgeuse marks his right shoulder, a red supergiant star nearing the end of its life. Betelgeuse is enormous. If you placed it where our sun is, it would swallow Mercury, Venus, Earth and Mars. It would reach almost to Jupiter. And it's dying. Astronomers expect it to explode in a supernova sometime in the next 100,000 years, though it could happen tomorrow or not for millennia. When it does explode, it will be bright enough to see during the daytime for weeks. It will be spectacular. But for now, Betelgeuse glows with a reddish hue, a dying ember in the shoulder of the hunter. Orion's left foot is marked by the star Rigel, a blue supergiant blazing with incredible intensity. Rigel is one of the most luminous stars visible to the naked eye, pouring out light at a rate that would overwhelm our sun. These stars, Betelgeuse and Rigel, are separated by about 500 light-years in space, but from Earth, They look like they're part of the same figure. That's the magic of perspective. Below Orion's belt hangs his sword, marked by a fuzzy patch that's not actually a star at all. It's the Orion Nebula, a vast cloud of gas and dust where new stars are being born. It's about 1,300 light-years away, one of the closest star-forming regions to Earth. Through a telescope, the Orion Nebula is breathtaking. Even with binoculars, you can see its cloudy structure. It's one of the few nebulae visible to the naked eye, a reminder that the universe is not static. Stars are being born right now, even as you read this, even as you drift towards sleep. Creation continues, patient and eternal. Then there's Ursa Major and Ursa Minor, the Great Bear and the Little Bear. In North America, most people know part of Ursa Major as the Big Dipper. 7 bright stars forming a ladle shape. The handle of the dipper is the bear's tail, and the bowl is its flank. But why would a bear have such a long tail? The Greek myth explains this. Zeus, king of the gods, fell in love with a nymph named Callisto. They had a son named Arcas, but Hera, Zeus's wife, was furious. She transformed Callisto into a bear as punishment. Years later, Arcas, now a grown man and a skilled hunter, encountered the bear in the forest. He didn't recognize his own mother. He raised his spear to kill her. Zeus, seeing what was about to happen, intervened. He transformed Arcas into a bear as well, then grabbed both bears by their tails and swung them up into the sky. The force of the throw stretched their tails into the long curves we see today. Mother and son, reunited in the stars, forever circling the North Star together. The North Star, Polaris, sits at the end of the handle of the Little Dipper, part of Ursa Minor. Polaris is not the brightest star in the sky, as many people think. It's actually only moderately bright. But it's the most important star for navigation in the Northern Hemisphere. Because of Earth's rotation and the orientation of Earth's axis, Polaris sits almost directly above the North Pole. It doesn't appear to move as Earth rotates. All the other stars wheel around it in great circles throughout the night, but Polaris stays fixed, steady, reliable. For thousands of years, travellers, sailors and explorers have used Polaris to find north. It's been a faithful guide through countless journeys, and it's still there tonight, shining with patient reliability, just as it always has. In the southern hemisphere, there's no equivalent star directly above the South Pole. Instead, navigators use the Southern Cross, or Crux, a small but distinctive constellation. 4 stars forming a cross shape pointing toward the South Celestial Pole. Ancient Polynesian navigators used the Southern Cross to sail across vast stretches of the Pacific Ocean, finding tiny islands in an enormous expanse of water. They read the stars like maps, and they were right. The stars didn't lead them astray. The cosmos is reliable in a way that few things in life are. Another famous constellation is Cassiopeia, the Queen. She sits in the northern sky, a distinctive W shape made of 5 bright stars. According to Greek mythology, Cassiopeia was a vain queen of ancient Ethiopia. She boasted that she was more beautiful than the sea nymphs, the Nereids. This angered Poseidon, who sent a sea monster to ravage the coast. The oracle said the only way to appease the monster was to sacrifice the queen's daughter, Andromeda. Andromeda was chained to a rock by the sea, awaiting her fate. But Perseus, fresh from slaying Medusa, flew by on his winged sandals. He saw Andromeda, fell in love, and rescued her by turning the sea monster to stone with Medusa's severed head. He married Andromeda, and they lived happily. But Cassiopeia, as punishment for her vanity, was placed in the stars in an awkward position. She's forced to circle the North Star upside down half the time, clinging to her throne to avoid falling out. It's a humbling reminder of the dangers of pride. Cygnus the Swan is another magnificent constellation, visible in summer and autumn in the Northern Hemisphere. It's sometimes called the Northern Cross because its brightest stars form a large cross shape. The head of the swan is marked by the star Alboreo, a beautiful double star. Even through a small telescope you can see that Alboreo is actually 2 stars, one golden yellow and one sapphire blue orbiting each other. They're stunning together, a cosmic jewel box. The body and wings of the swan stretch along the Milky Way, making Cygnus one of the most spectacular constellations to view in a dark sky. Greek. Mythology tells us that Cygnus represents several possible swans. One story says it's Zeus in swan form, seducing Leda, the Queen of Sparta. Another says it's Orpheus, transformed into a swan after his death and placed in the sky near his lyre, represented by the constellation Lyra. The swan flies along the Milky Way, as if following the river of stars across the cosmos. Leo the Lion is one of the zodiac constellations prominent in spring skies. Its distinctive sickle shape marks the lion's head and mane, while a triangle of stars forms its hindquarters. The bright star Regulus, whose name means Little King, marks the lion's heart. In Greek mythology, Leo represents the Nemean lion, a ferocious beast with impenetrable hide that terrorized the region of Nemea. It was immune to weapons. Hercules was sent to slay the lion as the first of his 12 labours. Unable to harm it with arrows or swords, Hercules wrestled the lion with his bare hands, eventually strangling it. He then used the lion's own claws to skin it, and he wore its pelt as armour for the rest of his life. The lion was placed in the stars to commemorate Hercules' victory. Leo is one of the few constellations that actually looks like what it's supposed to represent. The curve of stars forming the head and mane genuinely resembles a lion's profile, crouching in the grass, ready to pounce. Scorpius the Scorpion is a zodiac constellation visible in summer, low in the southern sky for northern hemisphere observers, but prominent for those in the south. The scorpion's distinctive curved tail and claws make it one of the easiest constellations to identify. The bright red star Antares marks the scorpion's heart. Antares is a red supergiant similar to Betelgeuse, massive and nearing the end of its life. Its name means rival of Mars because its red colour rivals the red planet. Antares is so large that if you placed it where our Sun is, its surface would extend past the orbit of Mars. It's dying, and when it finally explodes as a supernova, it will be spectacular. Scorpius, as we discussed earlier, is eternally linked to Orion. They're on opposite sides of the sky, chasing each other through the heavens in an endless cycle. When one rises, the other sets. The hunter and the scorpion, forever bound by myth and by the mechanics of Earth's rotation. Taurus the bull is a winter constellation, marked by the V-shaped Hyades cluster forming the bull's face, and the Pleiades cluster marking its shoulder. Aldebaran, a red giant, gleams as the bull's eye. In Greek mythology, Taurus represents Zeus in bull form. Zeus transformed himself into a beautiful white bull to approach Europa, a Phoenician princess. She was so captivated by the gentle bull that she climbed on its back. Zeus then revealed his true nature and carried her across the sea to the island of Crete, where he revealed himself, and she became the queen. The continent of Europe is named after her. Taurus also contains the Crab Nebula, this remnant of a supernova that exploded in the year 1054. Chinese and Arab astronomers recorded seeing a new star, so bright it was visible during the day, that appeared in Taurus and slowly faded over the following months. Today, we see the expanding cloud of debris from that explosion, still glowing, still spreading outward. It's one of the most studied objects in astronomy, a cosmic laboratory for understanding how stars die. Different cultures saw different patterns and told different stories. In Chinese astronomy, the stars were organized into different constellations representing an imperial bureaucracy. There were palaces, markets, military camps, and celestial officials. The Emperor of Heaven resided at the North Celestial Pole surrounded by his court. The stars were not gods but civil servants, each with specific duties. This reflected the Chinese worldview, where order and hierarchy were paramount. Aboriginal Australians, as mentioned, often saw dark constellations in the spaces between stars. The MU in the sky is formed by dark clouds of dust in the Milky Way. When visible, it spans from the Southern Cross all the way to Scorpius, The emu's head, body and legs are all clearly visible if you know where to look. This constellation was used to track the seasons as its orientation changed throughout the year, indicating when emus on Earth would be laying eggs. Ancient Egyptians saw the constellation we call Orion as Osiris, the god of death and resurrection. The 3 stars of Orion's belt aligned with the 3 great pyramids of Giza, and the positioning was deliberate. The pyramids were built to mirror the sky, creating a connection between earth and heaven. The pharaohs believed that in death, their souls would ascend to Orion and become one with Osiris, ruling the afterlife. The bright star Sirius, which rises shortly after Orion, was associated with the goddess Isis, Osiris's wife. The heliacal rising of Sirius, its first appearance in the dawn sky after a period of invisibility, coincided with the annual flooding of the Nile, the life-giving event that made Egyptian civilization possible. The Egyptians based their calendar on Sirius, making it one of the most important stars in their culture. Polynesian navigators used the stars to cross vast stretches of the Pacific Ocean, finding tiny islands in an enormous expanse of water. They memorized the rising and setting points of dozens of stars, using them like a compass. They knew which stars passed directly overhead at different latitudes, allowing them to maintain their position as they sailed. They could determine their latitude by observing which stars were visible and which were below the horizon. This navigation system, called wayfinding, was passed down orally through generations. It was nearly lost in the modern era, but has been revived by efforts to preserve indigenous knowledge. Today, wayfinding is practiced again, with navigators sailing traditional, double-hulled canoes across thousands of miles of ocean using only the stars, the waves and the behaviour of birds to guide them. It's a testament to human ingenuity and the deep connection between people and the night sky. All these constellations move across the sky throughout the night. Not because they're moving, but because Earth is rotating. From our perspective, it looks like the stars are wheeling overhead, rising in the east, crossing the sky, and setting in the west, just like the sun and moon. This daily motion is what creates the rhythm of night. It's predictable, calming. You can set your clock by the stars if you know what you're doing. They rise and set at the same times each night, shifting only slightly as Earth orbits the sun throughout the year. Throughout the year, different constellations become visible at different times. In winter, Orion dominates the northern sky. In summer, Cygnus the Swan stretches across the Milky Way. These seasonal changes happen because Earth orbits the sun, and our view of the night sky changes as we move through space. It's like being on a slowly turning carousel. The scenery changes gradually, predictably, beautifully. And every culture on Earth has used these changes to mark the passage of time. The stars were the first calendar, the first clock, the first way humanity measured the year. The beautiful thing about constellations is that they connect us to the past. The same patterns you see tonight were seen by ancient Egyptians building pyramids, by Babylonians mapping the heavens, by Chinese astronomers recording celestial events, by indigenous peoples all over the world telling stories around fires. The stars are the one constant across human history. Empires rise and fall. Languages evolve and die. But the stars remain. The patterns remain. And tonight, when you look up, you're seeing exactly what countless generations saw before you. You're part of an unbroken chain of stargazers, stretching back to the very beginning of human consciousness. And here's something even more soothing. The stars move so slowly through space that the constellations have barely changed in thousands of years. Betelgeuse has drifted slightly. Polaris wasn't always the North Star and won't always be in the future. But these changes take millennia. For your lifetime, for your children's lifetimes, for generations to come, the stars will look exactly as they do tonight. There's a deep stability in that, a reassurance that not everything changes. Some things remain, some things endure, and on nights when everything feels uncertain, you can look up and see the same patterns that have guided humanity since the dawn of time. That's comforting. That's grounding. That's exactly what you need as you settle into sleep tonight. So let the constellations be your companions tonight. Imagine them slowly wheeling overhead as you rest. Orion the hunter, Ursa Major and Minor the bears, Cassiopeia in her awkward throne, Cygnus, spreading its wings across the Milky Way, Leo the lion crouching, Scorpius curving its tail, Taurus the bull charging. They're all there, faithfully performing their nightly dance just as they have for billions of years, and they'll be there tomorrow night, and the night after, patient, eternal, unchanging. Let that steadiness calm your mind. Let the ancient patterns guide you into peaceful rest. The stars are watching over you, as they always have, and they're not going anywhere. Hanging in the night sky, often the first celestial object you notice is the moon, our closest companion in space, the only natural satellite of Earth. The moon has captured human imagination for as long as humans have existed. It's been worshipped as a god, feared as an omen, studied by scientists, immortalized in poetry. And it's still up there tonight, glowing with reflected sunlight, exactly where it's always been, faithful and constant, a gentle presence in the darkness. The moon doesn't produce its own light. It's not a star. It's a rocky world, smaller than Earth, orbiting our planet once every 27.3 days. The light we see from the moon is actually sunlight reflected off its surface. The moon's surface is covered in regolith, a fine grey dust created by billions of years of meteorite impacts. This dust reflects sunlight back to Earth, creating that soft silver glow we've all admired. The moon is dark grey in reality, but it appears bright against the darkness of space. Brightness is relative. Next to the void, even a dim reflection seems to shine. The moon goes through phases, a cycle that repeats every 29.5 days. This is called a lunar month. The phases occur because as the moon orbits Earth, we see different amounts of its sunlit side. When the moon is between Earth and the sun, we see the side that's in shadow. This is the new moon, invisible in the sky. A few days later, a thin crescent appears, hanging low in the western sky just after sunset. This is the waxing crescent, and it grows larger each night as more of the sunlit side becomes visible. About a week after the new moon, we reach the first quarter. Half the moon appears lit, though it's actually a quarter of the way through its cycle. The term quarter refers to the orbital position, not the appearance. Another week passes, and the moon becomes full. The full moon rises in the east just as the sun sets in the west. Earth, moon and sun are aligned, with Earth in the middle. The entire face of the moon facing us is illuminated. It's spectacular, bright enough to cast shadows, bright enough to read by, if you have good eyesight and patience. Then the moon begins to wane. The third quarter arrives a week later with half the moon visible again, but now on the opposite side. Finally, the waning crescent appears in the early morning sky, a thin sliver hanging above the eastern horizon before sunrise. Then the cycle begins again. New moon, waxing crescent. First, quarter, waxing gibbous. Full moon, waning gibbous. Third quarter, waning crescent. New moon. Over and over, month after month, year after year, for as long as the moon has existed. Predictable, reliable, soothing in its regularity. The moon's phases have been used to mark time for thousands of years. Many cultures base their calendars on the lunar cycle. The Islamic calendar is purely lunar, with months beginning at the first sight of the crescent moon. The Jewish calendar is lunisolar, incorporating both the moon's phases and the sun's yearly cycle. The Chinese calendar is also lunisolar. Even the word month comes from moon. The moon gave humanity one of its first ways to measure time beyond the simple cycle of day and night. The moon brought order to the darkness. But the moon does more than mark time. It moves the oceans. The moon's gravity pulls on Earth, creating tides. This is one of the most beautiful gravitational dances in the solar system. As the moon orbits Earth, its gravity pulls on our planet. Water, being fluid, responds most strongly to this pull. The oceans bulge toward the moon. But here's the interesting part. They also bulge on the opposite side of Earth. Why? Because the moon is pulling on the entire Earth, but it pulls slightly harder on the side closest to it, and slightly less on the far side. This differential force, called a tidal force, creates two bulges, one facing the moon, one facing away. As Earth rotates beneath these bulges, different parts of the planet experience high tide and low tide. Most coastal areas see 2 high tides and 2 low tides each day. The timing shifts each day by about 50 minutes because the moon is also orbiting Earth, moving about 12 degrees in its orbit each day. So the moon rises about 50 minutes later each day, and the tides follow that same delay. If high tide was at noon today, it'll be around 12:50 tomorrow. The ocean is literally following the moon across the sky. The sun also creates tides, though they're weaker than lunar tides. The sun is much more massive than the moon, but it's also much farther away. The strength of tidal forces depends on both mass and distance, and in this cosmic tug-of-war, the moon wins. Solar tides are about 40% the strength of lunar tides. But when the sun and moon align during new moon or full moon, their tidal forces combine. This creates spring tides, which are higher than normal. The name has nothing to do with the season. Spring here means to leap or jump. These are the highest high tides and lowest low tides of the month. When the sun and moon are at right angles to each other, during first quarter and third quarter, their tidal forces partially cancel out. This creates neap tides, which have the smallest difference between high and low tide. Neap comes from an Old English word meaning scant or poor. These tides don't leap, they barely rise at all. This monthly dance of spring and neap tides has shaped life on Earth. Coastal ecosystems depend on these rhythms. Creatures time their spawning to tidal cycles. Beaches shift and change with the tides. Harbours are built with tides in mind. The moon, silent and distant, orchestrates all of this without effort, just by existing, just by pulling gently on our planet as it passes. The moon formed about 4.5 billion years ago, not long after Earth itself. The leading theory is called the giant impact hypothesis. According to this idea, early in Earth's history, a Mars-sized object called Theia collided with the young Earth. The impact was catastrophic. It melted both worlds, vaporizing rock and flinging debris into orbit. The ejected material cooled and coalesced, forming the moon. This explains several strange facts about the moon. It's unusually large compared to Earth. Most moons in the solar system are tiny compared to their planets, but our moon is about a quarter the diameter of Earth. It's more like a double planet than a planet and satellite. The moon is also less dense than Earth, suggesting it formed from Earth's outer layers rather than including much of Earth's iron core. And the moon is tidally locked to Earth, meaning the same side always faces us. We never see the far side of the moon from Earth. This happened because of tidal forces. Over millions of years, Earth's gravity pulled on the moon, slowing its rotation until it matched its orbit. One side permanently faces Earth. The other side remains forever hidden. This far side was completely unknown until spacecraft photographed it in the 1950s. It's not dark. It receives just as much sunlight as the near side, but we can't see it from Earth. It's perpetually turned away, a hidden face that no humans saw until the space age. The moon's surface is marked by craters, the scars of billions of years of meteorite impacts. The large dark patches you can see with the naked eye are called maria, Latin for seas. Early astronomers thought they might be bodies of water. They're not. They're vast plains of solidified lava from ancient volcanic eruptions. Billions of years ago, the moon was geologically active. Asteroids crashed into the surface, fracturing the crust, and lava welled up from below, flooding the impact basins. Then the lava cooled and solidified, creating these dark regions. The maria are smoother than the lighter highland regions, which are older and more heavily cratered. Each mare has its own name, often poetic and beautiful. Mare Tranquillitatis, the Sea of Tranquility, is where Apollo 11 landed in 1969, where Neil Armstrong and Buzz Aldrin became the first humans to walk on another world. Mare Serenitatis, the Sea of Serenity, lies to the north, a perfectly circular dark patch. Mare Imbrium, the Sea of Rains, is one of the largest, formed by an impact so powerful it sent shock waves through the entire moon, creating mountain ranges on the opposite side. Mare Crisium, the Sea of Crises, is near, the eastern edge of the moon as we see it, a distinctive oval shape. These names were given by early astronomers who imagined the moon as a mirror of Earth, with oceans and continents, weather and life. They were wrong, but the names remain, carrying with them the dreams and hopes of generations who looked up and wondered what mysteries the moon might hold. If you look at the moon through binoculars or a small telescope, you can see these features in detail, craters within craters, testament to billions of years of bombardment. The larger craters have names, often honouring scientists, astronomers and explorers. Copernicus, a bright-rayed crater visible even to the naked eye as a small spot. Tycho near the moon's south pole, with bright rays extending outward for hundreds of miles, visible as a splash pattern. These rays are ejecta, material thrown out during the impact and scattered across the surface. Because this material is fresh and hasn't been darkened by space weathering, it appears bright. Mountain ranges rise along the edges of Maria, pushed up by the force of ancient impacts. Montes Apenninus, the lunar Apennines, form a curved range bordering Mare Imbrium. These mountains rise up to 3 miles high in places, jagged peaks catching the sunlight at the terminator, the boundary between the lit and unlit portions of the moon. The terminator is where the best lunar viewing happens. When the sun is low on the lunar horizon, shadows are long, and every crater, mountain and valley is thrown into sharp relief. A crater that's invisible when the sun is high overhead becomes dramatic and three-dimensional when the sun grazes its rim, filling half with light and half with shadow. Professional and amateur astronomers often observe the moon specifically along the terminator, watching as features emerge from darkness into light over the course of hours. It's a slow, meditative process, revealing the moon's topography in stunning detail. The moon's phases have cultural and agricultural significance across human history. The full moon has special names in different cultures, often related to seasonal activities. The harvest moon is the full moon closest to the autumn equinox, traditionally providing extra light for farmers harvesting their crops late into the evening. The hunter's moon follows in the next month when game was traditionally hunted in preparation for winter. Native American tribes gave each full moon a name: the wolf moon in January, when wolves howled outside villages; the snow moon in February; the worm moon in March, when the ground thawed and earthworms appeared; the pink moon in April, named for early blooming flowers; the flower moon in May; the strawberry moon in June, when strawberries ripened; the buck moon in July, when young buck deer grew new antlers; the sturgeon moon in August, when this fish was most abundant in lakes; the corn moon in September, harvest time; the hunter's moon in October; the beaver moon in November, when beavers built their winter dams and prepared for cold weather; the cold moon in December, marking the onset of winter. These names connected people to natural cycles, to the rhythm of the year, to the connection between sky and earth. Many traditional calendars are lunar. The Islamic calendar is purely lunar, with 12 lunar months totaling about 354 days. This means Islamic months drift through the seasons, completing a full cycle every 33 years or so. Ramadan, the month of fasting, can occur in summer or winter depending on the year. The Hebrew calendar is lunisolar, combining lunar months with adjustments to keep the calendar aligned with the solar year and the seasons. Extra months are added in certain years to keep Passover in spring. The Chinese calendar is also lunisolar, with complex rules for intercalation. The Lunar New Year falls on the second new moon after the winter solstice, typically in late January or February. Cultures around the world have found different ways to reconcile the moon's cycle with the sun's cycle, creating calendars that honour both. The moon has inspired countless works of art, literature and music. It's been a symbol of romance, mystery, madness. The word lunatic comes from luna, the Latin word for moon, based on the belief that the full moon could drive people insane. There's no scientific evidence for this, but the belief persists in folklore. The moon has been associated with femininity, with cycles, with change and transformation. In astrology, the moon represents emotions, the subconscious, nurturing. In tarot, the moon card symbolises illusion, intuition, the hidden aspects of reality. The moon appears in poetry as a silver coin, a pale ghost, a queen of the night. It's been painted, photographed, filmed, sung about. Claude Debussy's Clair de Lune, Moonlight, is one of the most beloved piano pieces ever written, evoking the quiet, shimmering beauty of moonlight on water. The moon is slowly drifting away from Earth. Tidal forces work both ways. Just as the moon pulls on Earth, Earth pulls on the moon. But because Earth is much more massive, it's slowing the moon's orbit, causing the moon to spiral outward at about 1.5 inches per year. It's a tiny amount, but over geological time it adds up. Billions of years ago the moon was much closer. The tides were enormous. Days were shorter because Earth was spinning faster. The moon appeared larger in the sky. Eclipses were more common and more dramatic. Everything was more intense. But gradually the system is settling. The moon is retreating. Earth's rotation is slowing. Eventually, in the distant future, Earth and moon will be tidally locked to each other, each showing only one face to the other, rotating and orbiting in perfect synchrony. But that won't happen for billions of years. For now, for your lifetime, for countless generations, the moon will continue its current dance, rising and setting, waxing and waning, pulling on the tides, lighting the night. The moon has been humanity's companion through everything. Every civilization that ever existed looked up at the moon. It's been a symbol of femininity, of cycles, of change and constancy combined. It's been measured and mapped, travelled to by 12 humans in the Apollo missions, the only extraterrestrial world humans have ever walked upon. Those footprints left by astronauts are still there, perfectly preserved in the airless regolith. They'll last for millions of years unless a meteorite happens to hit that exact spot. A monument to human achievement, quietly waiting on another world. The American flags planted at the landing sites have been bleached white by unfiltered solar radiation, but they still stand. The scientific instruments left behind still reflect laser beams fired from Earth, allowing precise measurements of the Earth-Moon distance. The abandoned lunar modules and rovers remain, exactly where they were left, frozen in time on the grey, silent surface. Tonight, wherever the moon is in its cycle, it's there for you. Whether it's a thin crescent or a blazing full moon, or invisible in the new moon phase, it's still there, still orbiting, still pulling on the oceans, still reflecting the sun's light. You can think of the moon as Earth's protective companion. Its gravity stabilizes Earth's axial tilt, preventing wild swings in climate. Without the moon, Earth's axis might wobble chaotically over time, causing extreme climate fluctuations that would make life difficult if not impossible. The moon keeps us steady. It's been doing that for billions of years, and it will continue long after we're gone. There's something deeply comforting about that. The moon is a guardian, a stabilizer, a gentle presence watching over our small blue world. As you drift towards sleep tonight, imagine the moon above you. Even if you can't see it through your ceiling, it's there. Imagine its grey surface, peaceful and still, marked with craters and maria, mountains and valleys. Imagine the Apollo landing sites forever preserved. Imagine the view from the moon, looking back at Earth. A blue and white marble hanging in the black sky, the only colour in sight. Imagine its slow orbit around Earth, completing another circuit. Imagine the tides responding to its gravity. the oceans rising and falling with slow, patient rhythm. The moon asks nothing of you. It simply exists, and in its existence it shapes your world in subtle but profound ways. Let the moon's constancy calm your mind. Let its ancient surface remind you that change happens slowly, that stability is possible, that some things endure. The moon has been here through everything, and it will be here tomorrow, faithful, unchanging, a silver companion in the darkness. Rest well beneath its gentle light. On certain nights, if you look carefully at the sky, you might notice something strange. A bright point of light that doesn't twinkle like the stars. It shines with steady, calm light. This might be a planet. The ancients called them wandering stars because they move against the fixed background of constellations. The word planet comes from the Greek planets, meaning wanderer. And these wanderers have fascinated humans for thousands of years. 5 planets are visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. These planets have been known since ancient times, observed by Babylonian astronomers, Greek philosophers, Chinese stargazers, and every culture that looked up. They were mysteries then, moving lights in the sky that didn't follow the same rules as stars. They were often associated with gods. The Romans named them after their deities, and those names stuck. Mercury, the swift messenger; Venus, the goddess of love and beauty; Mars, the god of war; Jupiter, the king of the gods; Saturn, the god of time and agriculture. Venus is the easiest planet to spot. It's the brightest object in the night sky after the moon. Sometimes called the evening star or the morning star, Venus appears either just after sunset in the western sky or just before sunrise in the eastern sky. It never gets far from the sun in our sky because Venus orbits closer to the sun than Earth does. We can only see it during twilight, but when Venus is visible, it's unmistakable. Brilliant, steady, white light. So bright it can cast shadows on a moonless night. So bright that people sometimes call the police thinking it's a UFO. Venus is Earth's sister planet in size, but utterly different in every other way. It's wrapped in thick clouds of sulfuric acid. Its atmosphere is 90 times denser than Earth's, creating a crushing pressure at the surface. The greenhouse effect has gone wild on Venus, raising surface temperatures to over 800 degrees Fahrenheit, hot enough to melt lead. It's a hellish world, and yet from Earth it looks like a pearl. Beautiful, serene, deceptive. Mars is the red planet, and its colour makes it distinctive. It glows with a rusty orange hue. Mars has captivated human imagination for centuries. Its colour associated it with blood and war in ancient cultures. In the late 1800s, astronomers thought they saw canals on Mars, leading to speculation about Martian civilizations. Those turned out to be optical illusions, but the fascination remained. Mars is cold, dry, with a thin atmosphere, but it once had rivers and possibly oceans. Spacecraft have found abundant evidence of ancient water. Today Mars is a frozen desert, but it's the most Earth-like planet in the solar system, and humans dream of going there someday. Jupiter is the giant of the solar system, a massive world more than 11 times the diameter of Earth. Even though it's much farther from the Sun than Venus, Jupiter can still be very bright in our sky because of its enormous size. Through binoculars, you can see Jupiter as a tiny disk rather than a point, and if you look closely, you can see up to 4 of its largest moons: Io, Europa, Ganymede, and Callisto. These are the Galilean moons discovered by Galileo in 1610 when he first turned a telescope to the sky. Seeing these moons orbit Jupiter was one of the first pieces of evidence that not everything orbits Earth. It was revolutionary. It changed everything. And you can see those same moons tonight with a simple pair of binoculars. You're replicating one of the most important observations in the history of science. Saturn is the jewel of the solar system because of its rings. But sadly, you can't see the rings with the naked eye. Saturn appears as a bright yellowish star. Through even a small telescope, though, the rings appear and they're breathtaking. Saturn is farther from the Sun than Jupiter, dimmer, but still bright enough to be prominent. The rings are made of countless chunks of ice and rock, ranging from tiny grains to house-sized boulders, all orbiting Saturn in a flat disk. They're thin. If you scaled Saturn down to the size of a basketball, the rings would be thinner than a sheet of paper, but they stretch out nearly 200,000 miles from the planet. They're beautiful. Temporary, too. The rings are slowly falling into Saturn. In a few 100 million years, they'll be gone. We're lucky to live in an era when Saturn has rings to show us. Mercury is the hardest of the bright planets to spot because it never gets far from the Sun. It hugs close to the solar neighbourhood, visible only during twilight, low on the horizon, usually obscured by haze or blocked by buildings. But if you catch it, Mercury appears as a bright star low in the sky just after sunset or just before sunrise. It moves quickly across the sky over the course of days and weeks. The ancients noticed this and named it after the swift messenger god. These 5 planets have been companions to humanity for all of recorded history. They move through the zodiac constellations, taking months or years to complete their wandering paths across the sky. Ancient astronomers tracked their movements carefully, noticing patterns. They realized the planets don't always move forward against the stars. Sometimes they slow down, stop, and move backward for a while before resuming their forward motion. This is called retrograde motion, and it puzzled astronomers for thousands of years. The explanation is perspective. Planets don't actually move backward. They just appear to because we're watching them from Earth, which is also moving. Imagine driving on a highway. You're in the right lane, and a faster car in the left lane passes you. From your perspective, the car appears to move forward quickly, but then you speed up and start passing a slower car. For a moment, as you overtake it, the other car seems to move backward relative to you, even though both cars are moving forward. That's retrograde motion. When Earth, in its smaller, faster orbit, overtakes Mars, Jupiter, or Saturn, those planets appear to move backward against the stars for a while. Then, as Earth continues on and the geometry changes, they resume their forward motion. This retrograde motion was difficult to explain in ancient models of the cosmos, where Earth was at the centre of everything. Astronomers invented complex systems of epicycles, circles within circles, to account for these movements. It worked mathematically, but it was complicated. When Copernicus placed the Sun at the centre and had the planets orbit it, retrograde motion became simple. It was just perspective, an observer on a moving planet watching other moving planets. Elegant, natural, true. The planets move through the zodiac, the 12 constellations that lie along the ecliptic, the apparent path of the Sun across the sky. The ecliptic is actually the plane of Earth's orbit around the Sun, and because all the planets orbit the Sun in roughly the same plane, they all appear to move through the same narrow band of sky, the zodiac. Ancient astronomers divided this band into 12 sections, giving us the familiar astrological signs: Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, Capricorn, Aquarius, Pisces. The planets wander through these constellations, spending weeks or months in each. Watching the planets over weeks and months is like watching a slow, graceful ballet. Jupiter might be in Taurus one month, then slowly move toward Gemini. Mars might be in Virgo, glowing red against the background stars. Venus might shine brilliantly in Pisces at sunset. These movements are predictable, calculable, beautiful. Ancient astronomers could predict planetary positions years in advance. Modern astronomers can calculate them with incredible precision. The planets follow the laws of physics, the same laws that govern everything in the universe. They orbit the Sun not out of choice but out of necessity. Gravity guides them. The Sun's immense mass curves space-time, and the planets follow those curves like marbles rolling in a bowl. There's something soothing about watching the planets. They're not just points of light. They're worlds, entire planets with atmospheres, moons, storms, geology, Venus with its crushing heat, Mars with its ancient river valleys, Jupiter with its great red spot, a storm larger than Earth that's been raging for centuries, Saturn with its impossible rings, Mercury, scorched by the sun, all of them orbiting peacefully, following their eternal paths. And from Earth, we see them as bright, steady lights, wanderers in the darkness, companions on our journey through space. If you go outside tonight and see a bright, steady light that doesn't twinkle, take a moment to appreciate what you're seeing. That's not a star. That's an entire world. Hundreds of millions of miles away perhaps, but real, solid. A place you could theoretically visit if we had the technology and time. Think about that. The light reflecting off Venus right now, the light your eye receives, bounced off another planet. It travelled across the inner solar system and reached you. You're seeing another world. How extraordinary is that? As you close your eyes tonight, imagine the planets in their orbits. Imagine Mercury racing close to the Sun, completing its orbit in just 88 days. Imagine Venus shrouded in clouds reflecting sunlight brilliantly. Imagine Mars cold and rusty, its dust storms occasionally covering the entire planet. Imagine Jupiter, massive and turbulent, with storms and lightning in its thick atmosphere. Imagine Saturn, serene and ringed, slowly completing its orbit over 29 years. All of them moving, orbiting, following the laws of nature. They don't rush, they don't panic, they simply move at the pace gravity dictates. And that's enough. Let the steady, patient motion of the planets calm your thoughts tonight. They've been orbiting for billions of years. They'll continue for billions more. They don't need you to watch them. But tonight, you watched. And that's a gift. Rest peacefully knowing the cosmic ballet continues above, whether you're awake or asleep. On a truly dark night, far from city lights, you might notice something remarkable stretching across the sky. A faint glowing band of light, soft and milky. Ancient cultures saw it and wondered. Some thought it was the path to heaven. Others saw it as a river of stars. The Greeks called it Galaxias Kyklos, the Milky Circle. We call it the Milky Way. And it's not just a cloud of light. It's home. It's our galaxy. The enormous spiral of stars, gas and dust that contains our sun, our solar system, and everything we can see with the naked eye. The Milky Way contains between 100 billion and 400 billion stars. The exact number is uncertain because we can't see most of them. They're hidden behind dust, or they're too faint, or they're on the other side of the galaxy. But they're there. Hundreds of billions of suns, many with their own planets, spread across a disk roughly 100,000 light-years in diameter. Our sun sits about 26,000 light-years from the centre, out in a spiral arm. We're not in the centre, we're not on the edge, we're in the suburbs of the galaxy. A comfortable middle distance where conditions are stable. Not too much radiation from the crowded core, not too isolated in the empty outskirts, just right for life to develop and thrive. When you look at the Milky Way stretching across the sky, you're seeing our galaxy edge on from the inside. Imagine being inside a flat disk. If you look toward the centre of the disk, you see many stars layered in depth. If you look perpendicular to the disk, you see fewer stars. The Milky Way appears as a band because we're seeing the disk from within. All those stars blend together into that soft glowing river of light. Each point of light in the Milky Way is a star, sometimes hundreds or thousands of light years away. Too far to see individually, but collectively they create that luminous glow. The centre of our galaxy lies in the direction of Sagittarius, near the southern horizon for observers in the northern hemisphere. This is the brightest and most spectacular part of the Milky Way. The galactic core is dense with stars, gas and dust, and at the very centre, hidden by all that material, is a supermassive black hole. It's called Sagittarius A star. and it's about 4 million times the mass of our Sun. The black hole itself is invisible, but astronomers can detect it by watching stars orbit something they can't see. Stars near the galactic centre move at incredible speeds, whipping around an invisible point in tight orbits. The only explanation is a massive black hole. It's lurking there at the heart of our galaxy, pulling everything toward it with immense gravity, though thankfully we're far enough away that it doesn't affect us. The Milky Way is a barred spiral galaxy. It has a central bar-shaped structure made of stars, with spiral arms curving out from the ends of the bar. These arms are where star formation happens most actively. Clouds of gas and dust collapse under their own gravity, igniting nuclear fusion and forming new stars. The arms glow with the light of young, hot blue stars and the pink glow of ionized hydrogen in star-forming nebulae. Our Sun is located in the Orion Arm, sometimes called the Orion Spur, a smaller arm between two major spiral arms. It's a relatively quiet area of the galaxy. And that's good for us. Too close to a star-forming region, and we'd be bathed in radiation from supernova and massive stars. Too close to the centre, and the density of stars might destabilise planetary orbits. But here, in our suburban location, things are calm. The Milky Way is moving too. It's not stationary. The entire galaxy is rotating. Our Sun takes about 230 million years to complete one orbit around the galactic centre. That's called a galactic year. The last time the Sun was in this position, dinosaurs were starting to walk the Earth. The Sun has only completed about 20 orbits in its entire 4.5 billion year lifetime. It's a slow dance, a cosmic waltz, but it's constant. And every star in the galaxy is performing the same dance, each at their own pace depending on their distance from the centre. The Milky Way is also moving through space. Galaxies are not fixed in place. They're moving relative to each other, pulled by gravity, coasting through the expanding universe. Our galaxy is part of a small cluster called the Local Group, which includes the Andromeda Galaxy, the Triangulum Galaxy, and several dozen smaller dwarf galaxies. The Milky Way and Andromeda are the two largest members of this group, and they're moving toward each other. In about 4 billion years they'll collide, or rather they'll merge. Galaxies don't collide like cars crashing. The stars are too spread out. Two galaxies can pass through each other with almost none of the individual stars actually hitting anything, but gravity reshapes both galaxies. They pull on each other, distorting their structures, eventually merging into a single larger galaxy. It will be spectacular if anyone's around to see it. The night sky will be ablaze with stars as Andromeda looms larger and larger. Then the two galaxies will blend, their stars mingling, their black holes spiralling inward until they merge at the new centre. Our Sun will likely survive. It will end up in a different part of the merged galaxy, but it will still be there, still shining. Life on Earth, however, will long since have ended by then, for other reasons. But that's billions of years in the future. Tonight the Milky Way is peaceful, a glowing river across the darkness. To see it properly you need dark skies. Light pollution is the enemy of the Milky Way. City lights wash out the faint glow of distant stars. The brighter the surroundings, the less you can see. In a major city you might see only a handful of stars on a clear night. In a suburban area you can see hundreds. But in a truly dark place, a place designated as a dark sky reserve or simply far from human habitation, you can see thousands of stars, and the Milky Way becomes obvious. It stretches from horizon to horizon, a river of light with dark rifts cutting through it. Those dark rifts are not empty space. They're clouds of dust blocking the light from stars behind them. One famous dark rift is called the Great Rift, running through the Milky Way in the summer sky. It looks like a dark river cutting through the light. Ancient cultures noticed this. Some saw it as a pathway. Others saw it as a cosmic void. Aboriginal Australians created constellations from these dark patches, rather than the stars themselves, seeing shapes in the darkness. The Emu in the sky, for example, is a dark constellation visible in the Australian autumn. stretching from the Southern Cross towards Scorpius. It's a reminder that the Milky Way is not just light, it's light and dark, stars and dust, creation and emptiness all blended together. Light pollution is erasing the Milky Way for most people. Studies suggest that more than 80% of people in North America cannot see the Milky Way from where they live. The skies are too bright, the stars are too faint, and a generation is growing up without ever seeing the natural night sky. They don't know what they're missing. They don't know that on a dark night, away from lights, the sky is not black. It's filled with stars. It's alive with light. The Milky Way is not some rare phenomenon visible only with telescopes. It's a naked eye wonder. You just need darkness to see it. If you ever have the chance to visit a dark sky site, do it. Drive out to the countryside, visit a national park, go to the desert or the mountains, get away from the city. Let your eyes adjust to the darkness for at least 20 minutes, and then look up. The Milky Way will be there, stretching across the sky. A sight that has inspired humans for millennia. It's humbling. It's awe-inspiring. It's peaceful. Looking at the Milky Way reminds you that you're part of something vast. You're standing on a small planet, orbiting an average star in a suburban spiral arm of a galaxy containing hundreds of billions of stars. And that galaxy is just one of trillions in the observable universe. You're tiny, but you're connected to all of it. You're made of star stuff, as Carl Sagan said. The atoms in your body were forged in the cores of stars that lived and died before the sun was born. You're literally made of the galaxy. You're not separate from it. You're part of it. Tonight, even if you can't see the Milky Way from where you are, you can imagine it. Picture that glowing band arcing across the sky. Picture the billions of stars it contains. Picture the spiral arms, the dust lanes, the star-forming regions glowing pink. Picture the supermassive black hole at the centre, quietly pulling on everything around it. Picture our sun, a tiny yellow dot in one of the spiral arms, with Earth, an even tinier blue dot, orbiting around it. And picture yourself looking up, thinking about the galaxy, feeling connected to it. That connection is real. And it's peaceful. Let the thought of the Milky Way calm you tonight. Let the vastness comfort you. Let the knowledge that you're part of something enormous and ancient and beautiful ease you into sleep. The galaxy is up there, slowly rotating, shining steadily, and you're safe within it. Rest well beneath the galactic light. Sometimes, if you're patient and you watch the sky long enough, you'll see a streak of light. Brief. Brilliant. A flash that crosses the sky in a second or two and vanishes. A shooting star. That's what most people call them, though they're not stars at all. They're meteors, tiny pieces of rock or dust burning up in Earth's atmosphere, and they're one of the most magical sights in the night sky. Meteors are evidence that space is not empty. It's filled with debris, dust from comets, fragments from asteroids, particles left over from the formation of the solar system, all of it drifting through space, invisible, until it encounters a planet. And when Earth, moving through space at about 67,000 miles per hour, slams into one of these particles, the particle doesn't stand a chance. The particle enters Earth's atmosphere at tremendous speed. Friction with air molecules heats it to thousands of degrees. The particle vaporizes, leaving a glowing trail of ionized air behind it. That trail is what we see as a meteor, a shooting star. The particle itself is often no larger than a grain of sand, sometimes smaller, but the glow can be visible for hundreds of miles. Most meteors occur between 50 and 80 miles above the ground, high in the atmosphere where the air is thin but still present enough to create friction. On any given night, if you watch the sky for an hour, you might see several sporadic meteors. These are random particles, unrelated to each other, entering the atmosphere from random directions. But on certain nights of the year, the rate increases dramatically. You might see dozens of meteors per hour, all appearing to radiate from the same point in the sky. These are meteor showers, and they occur when Earth passes through the debris trail left by a comet. Comets are icy bodies that orbit the Sun in long elliptical paths. As a comet approaches the Sun, solar heat vaporizes some of the ice, releasing dust and gas. This creates the comet's tail, but it also leaves a trail of debris along the comet's orbit. Each time the comet passes, it deposits more dust. Over thousands of years, the orbit becomes filled with tiny particles. When Earth's orbit intersects this debris trail, we get a meteor shower. Each meteor shower is associated with a specific comet, and each has a radiant point, a location in the sky from which the meteors appear to radiate. The shower is named after the constellation containing the radiant. The Perseids radiate from Perseus, the Leonids from Leo, the Geminids from Gemini. The radiant point is an illusion of perspective. The meteors are actually travelling on parallel paths, but because of perspective, they appear to spread out from a single point. It's like standing on a highway and watching the dashed lines on the road. The lines are parallel, but they appear to converge toward a vanishing point in the distance. The Perseids are one of the most popular meteor showers. They occur every August, peaking around the 12th or 13th. The Perseids are fast and bright, often leaving persistent trains, glowing trails that linger for seconds. They're associated with Comet Swift-Tuttle, which last passed through the inner solar system in 1992. The comet won't return until 2026, but its debris trail remains, orbiting the Sun, waiting for Earth to pass through it every August. On a good year, the Perseids can produce 60 to 100 meteors per hour during the peak, though you'll need dark skies to see them all. The Geminids occur in December, peaking around the 13th or 14th. They're unusual because they're associated not with a comet but with an asteroid called 3200 Phaethon. This asteroid may be an extinct comet, a comet that's lost all its volatile ices and now resembles an asteroid. The Geminids are slow and bright, often producing colourful meteors, yellow, green, even red. They're reliable, often producing more than 100 meteors per hour during the peak. The Leonids peak in November and are known for their periodic meteor storms. Most years the Leonids produce only about 15 meteors per hour, but every 33 years, when the parent comet, Comet Tempel-Tuttle, returns, the Leonids can produce spectacular storms with thousands of meteors per hour. The last great storm was in 1999, when observers reported meteors at rates of thousands per hour. It was described as a celestial snowstorm, the sky filled with streaks of light. The next storm is expected around 2033. Watching a meteor shower is a meditative experience. You need patience, a dark sky, a reclining chair or blanket, and time. You lie back, look up, and wait. Minutes might pass with nothing. Then, a flash. A meteor streaks across the sky. Then another. Then nothing for a while. Then 3 in rapid succession. It's unpredictable. That's part of the magic. You can't control it. You can only watch. Let your mind wander. Let your thoughts drift. And every so often the universe rewards you with a streak of light. A reminder that you're on a planet moving through space. A reminder that the solar system is full of debris, leftovers from creation. A reminder that everything is in motion. Nothing is truly still. Meteors remind us that Earth is not isolated. We're part of the solar system. We're moving through space, sweeping up dust and particles as we go. Most of it burns up harmlessly. Occasionally a larger chunk makes it through. We call those meteorites, pieces of space rock that survive the fiery descent and land on Earth. People have found meteorites throughout history, not understanding what they were. Iron meteorites were used to make tools and weapons before humans learned to smelt iron. Meteorites were considered magical, gifts from the gods. In a sense, they are. They're pieces of other worlds. Fragments from the asteroid belt, chips from the moon, blasted off by impacts and eventually captured by Earth's gravity. Even pieces from Mars, ejected by impacts and journeying through space for millions of years before landing here. You can hold a meteorite in your hand, a rock that's been in space, that's travelled farther than any human, that's older than Earth itself. It's humbling. Tonight, if you have the chance, go outside and watch the sky for a while. You don't need a meteor shower. Sporadic meteors happen all the time. Just be patient, watch, breathe. Let the night settle around you and wait for the flash. When you see it, make a wish if you like. That's the tradition. Shooting stars are supposed to grant wishes. It's nonsense, of course, but it's harmless, hopeful nonsense. And hope is a good thing to carry into sleep. So watch for meteors, wish on them, and let the brief, beautiful flashes remind you that the universe is full of wonders, small wonders, fleeting wonders, but wonders nonetheless, and they're happening all the time whether you're awake to see them or not. Rest peacefully knowing that above you, the cosmic fireworks continue. If you've ever been fortunate enough to visit the far north or the far south, you may have witnessed one of nature's most breathtaking displays. Curtains of light dancing across the sky, shimmering veils of green, sometimes red, sometimes purple, rippling and swirling in silent motion, the aurora. In the north, it's called the aurora borealis or northern lights. In the south, the aurora australis or southern lights. And though they appear magical, almost supernatural, they're the result of physics, beautiful physics, a dance between the sun and earth, played out in the upper atmosphere. The story of an aurora begins 93 million miles away, on the surface of the sun. The sun is not calm. It's a churning ball of plasma, heated by nuclear fusion in its core, roiling with magnetic fields, erupting with flares and ejecting massive clouds of charged particles. This stream of particles flowing from the sun is called the solar wind. It's always there, blowing through the solar system at speeds of around 1 million miles per hour. Earth sits in this wind, a small blue marble bathed in solar radiation. But we're protected. Earth has a magnetic field, generated by the motion of molten iron in its outer core. This magnetic field extends far into space, creating a protective bubble called the magnetosphere. The magnetosphere deflects most of the solar wind, channeling it around Earth like a river flowing around a rock. But the solar wind doesn't give up easily. When it encounters the magnetosphere, it compresses it on the side facing the sun and stretches it out into a long tail on the night side of Earth. And when conditions are right, especially when the solar wind is strong and the magnetic field carried within it is oriented opposite to Earth's magnetic field, the two can connect. Magnetic field lines from the sun link with magnetic field lines from Earth in a process called magnetic reconnection. This allows particles from the solar wind to enter the magnetosphere. These particles, mostly electrons and protons, follow Earth's magnetic field lines, and those field lines converge at the poles, so the particles are funneled toward the Arctic and Antarctic regions. As these charged particles spiral down the field lines, they enter the upper atmosphere, colliding with atoms and molecules of oxygen and nitrogen. These collisions transfer energy. The atoms become excited, electrons jumping to higher energy levels, but excited states are unstable. The electrons fall back down to their normal levels, and when they do, they release the extra energy as light. This is the aurora. The glow of the upper atmosphere, energized by particles from space. The colour of the aurora depends on which atoms are involved and at what altitude the collisions occur. Green is the most common colour, produced by oxygen atoms at altitudes of about 60 to 150 miles. This is the classic auroral green, the colour you see in most photographs. Red auroras, rarer and often faint, are produced by oxygen at higher altitudes, above 150 miles. The air is thinner there, and collisions are less frequent, but when they happen, they produce a deep red glow. Purple and blue colours come from nitrogen. Blue appears at lower altitudes, purple at higher. Sometimes you see all these colours at once, creating a multi-hued display that ripples and dances across the sky. Auroras are not static. They move, they pulse, they flicker. This is because the solar wind is not constant, it fluctuates. The magnetosphere responds to these fluctuations, and the flow of particles into the atmosphere changes accordingly. Auroral arcs can stretch across the entire sky. Thin ribbons of light. Curtains can ripple like fabric blowing in a breeze. Coronas can form overhead, where the aurora appears to radiate from a central point directly above you. This happens when you're standing beneath an arc that extends along the magnetic field lines converging above you. It's like standing under a canopy of light. It's surreal. Auroras occur most frequently near the magnetic poles, in regions called the auroral ovals. These are ring-shaped zones centered on the magnetic poles, roughly 10 to 20 degrees in radius. If you live within these zones, like in northern Canada, Alaska, Scandinavia or Iceland, you can see auroras frequently, sometimes several nights a week, but during periods of high solar activity the auroral ovals expand. Strong geomagnetic storms can push auroras much farther south, making them visible in places where they're normally never seen. Auroras have been spotted as far south as Florida and southern Europe during particularly powerful storms. The sun goes through an 11-year cycle of activity, from solar minimum, when the sun is relatively quiet, to solar maximum, when it's covered with sunspots and erupts frequently with solar flares and coronal mass ejections. We're currently approaching solar maximum in the 2020s, which means auroras are becoming more frequent and more intense. This is the best time in over a decade to see them. If you live at mid-latitudes, there's a chance you might see an aurora during a strong geomagnetic storm. It's worth watching for alerts from space weather services. When a strong storm is forecast, it's worth going outside and looking north on a clear, dark night. You might see a red glow on the northern horizon, or arcs of green light, or if you're very lucky, a full display dancing overhead. Auroras are silent, or at least we think they are. There have been rare reports of sounds associated with auroras, a crackling or hissing noise. Scientists are still debating whether these sounds are real or psychological. If they're real, they might be caused by localized electrical discharges near the ground triggered by changes in Earth's magnetic field during auroral activity. But most of the time, auroras are completely silent. It adds to their surreal quality. Curtains of light rippling across the sky with no sound at all. It's like watching a dream. Auroras have been part of human culture for thousands of years. Indigenous peoples in the Arctic have many myths about them. Some saw them as spirits of the dead dancing in the sky. Others saw them as celestial battles, warnings, omens. The Vikings believed that auroras were reflections from the shields and armour of the Valkyries, the warrior maidens who chose who would die in battle and be taken to Valhalla. In Finnish folklore, auroras were called revontulet, meaning foxfires. The legend said that a magical fox ran across the snow, sweeping his tail and sending sparks into the sky. Even the scientific name, Aurora Borealis, comes from myth. Aurora was the Roman goddess of dawn, and Boreas was the Greek god of the north wind. Today, auroras are a source of wonder and tourism. People travel to places like Iceland, northern Norway and Alaska, specifically to see them. Hotels and tour companies cater to aurora hunters, offering guided trips into the wilderness where light pollution is minimal. Photographers spend hours in the cold, cameras clicking, capturing the dance of the lights, and it's worth it. An aurora is not something a photograph can truly capture. You have to be there. You have to see it with your own eyes. The way it moves, the way it fills the sky, the way it makes you feel small and connected at the same time. Auroras also occur on other planets. Jupiter and Saturn have auroras, powered by their own magnetic fields and the solar wind. Jupiter's auroras are particularly intense because Jupiter's magnetic field is enormous, and the planet also receives charged particles from volcanic eruptions on its moon Io. These particles get trapped in Jupiter's magnetosphere and eventually slam into the atmosphere near the poles, creating auroras far more powerful than anything on Earth. Spacecraft have photographed these alien light shows glowing at the poles of distant giants. It's a reminder that auroras are a universal phenomenon. Anywhere there's a magnetosphere, an atmosphere, and charged particles, there can be auroras. Tonight, even if you're far from the auroral zones, you can imagine them. Picture the solar wind streaming from the sun, particles racing through space. Picture Earth's magnetic field, a protective bubble deflecting most of the onslaught but channeling some toward the poles. Picture the collisions in the upper atmosphere, oxygen atoms glowing green, nitrogen flickering purple. Picture the curtains of light, swaying gently in the magnetic breeze. Picture the silent dance, ancient and eternal. Let the image calm you. Let the knowledge that somewhere, right now, auroras are glowing over the Arctic and Antarctic bring you peace. The universe is full of beauty, and sometimes that beauty reaches down and touches Earth, lighting up the night in colours we barely have words for. Rest well beneath the sky, knowing that above, the cosmic dance continues. When you look up at the night sky, most of what you see are individual stars. But if you look closely, especially if you're away from light pollution, you'll notice some fuzzy patches, areas where the stars seem to cluster together, or glowing clouds where no distinct stars are visible. These are deep sky objects, star clusters, nebulae, and distant galaxies. Most require telescopes to see in detail, but a few are visible to the naked eye, and they're worth seeking out. They're windows into the broader universe. Proof that space is not empty. It's filled with structure, with clouds of gas, with groups of stars bound by gravity, with entire galaxies wheeling through the void. The Pleiades, also known as the Seven Sisters, are one of the most famous star clusters in the sky. They're located in the constellation Taurus, the Bull, and they're visible from almost everywhere on Earth. To the naked eye, the Pleiades appear as a small dipper-shaped group of stars. Most people can see 6 or 7 stars, though sharp-eyed observers in dark skies can spot up to 14. Through binoculars, the cluster becomes stunning. Dozens of stars appear, hot blue giants embedded in faint wisps of nebulosity. The Pleiades are about 440 light-years away and are relatively young, only about 100 million years old. The stars formed from the same cloud of gas and are still loosely bound together by gravity. Eventually they'll drift apart, but for now they're a family, a stellar sibling group. The Hyades are another star cluster in Taurus, forming the V-shape of the Bull's face. Aldebaran, the bright orange eye of the Bull, appears to be part of the Hyades, but it's actually a foreground star, much closer to us. The Hyades themselves are about 150 light-years away, making them one of the closest star clusters to Earth. Because they're so close, the individual stars are spread out across a wide area of the sky. Through binoculars you can see dozens of them. The Hyades are older than the Pleiades, about 600 million years old. Their stars are cooling, turning from blue to yellow to orange as they age. The Beehive cluster, also known as Praesepe, or M44, is a star cluster in the constellation Cancer. It's visible to the naked eye as a faint smudge, but through binoculars or a telescope, it resolves into dozens of stars. The ancient Greeks knew about it. They called it the manger, imagining that 2 nearby stars were donkeys feeding from it. The Beehive is about 600 light-years away and contains about 1,000 stars. It's a beautiful sight in a small telescope. The stars twinkle like diamonds scattered across black velvet. The Andromeda Galaxy is the most distant object visible to the naked eye. It's about 2.5 million light-years away. The light you see from Andromeda tonight left that galaxy 2.5 million years ago, when our ancestors were early hominids just beginning to use stone tools. Andromeda appears as a faint, fuzzy oval in the constellation Andromeda, visible on autumn evenings in the northern hemisphere. It's hard to see from light-polluted areas, but in a dark sky, it's unmistakable. Through binoculars, you can see its elongated shape. Through a telescope you might glimpse the spiral structure and some of the dust lanes, but no matter how you see it, Andromeda is profound. It's an entire galaxy, trillions of stars, hundreds of billions at least, planets, perhaps life, all contained in that faint smudge, and you can see it with your naked eye. You're seeing across intergalactic space. You're looking at another galaxy. How extraordinary is that? The Orion Nebula is one of the most famous nebulae in the sky. It's visible as a fuzzy patch in Orion's sword, hanging below his belt. Even with the naked eye, you can tell it's not a star. Through binoculars, it's clearly a glowing cloud. Through a telescope, it's magnificent. The Orion Nebula is a stellar nursery, a place where new stars are being born. It's about 1,300 light-years away, and it's huge. If the Sun were at the centre of the Orion Nebula, the nebula would stretch out past Earth's orbit. The glow comes from hydrogen gas ionized by the ultraviolet light from young hot stars embedded in the cloud. These stars, called the trapezium because of their arrangement, are visible even in small telescopes. They're less than 1 million years old, babies by stellar standards, and they're sculpting the nebula, their stellar winds blowing away gas and creating the beautiful shapes we see. There are other nebulae visible with binoculars or small telescopes: the Lagoon Nebula, the Trifid Nebula, the Eagle Nebula. Each one is a star-forming region, a place where gravity is pulling gas together, compressing it until it ignites into fusion. These nebulae glow pink or red because of ionized hydrogen, and they're often laced with dark dust lanes where light is blocked. They're beautiful, delicate structures carved by stellar winds and radiation. They're also temporary. In a few million years, the stars will finish forming, the gas will be blown away or consumed, and the nebula will disappear. But new nebulae will form elsewhere. The process is ongoing. Stars are constantly being born in galaxies across the universe. Creation never stops. Globular clusters are dense balls of stars orbiting galaxies. The Milky Way has about 150 globular clusters. Most are too faint to see without a telescope, but a few are visible with binoculars. M13, the Great Globular Cluster in Hercules, is the best example in the Northern Hemisphere. Through binoculars, it appears as a fuzzy ball. Through a telescope, it resolves into thousands of stars packed tightly together, like a swarm of glowing bees. Globular clusters are ancient. They contain some of the oldest stars in the galaxy, 12 to 13 billion years old. They formed shortly after the Milky Way itself, and they orbit in the galactic halo, the spherical cloud of stars and dark matter surrounding the galactic disk. They're survivors, relics from the early universe. Looking at a globular cluster is like looking at cosmic history. Those stars have been shining since long before the Sun existed. Each of these objects tells a story. The Pleiades tell the story of youth, of stars just beginning their lives. The Heads tell the story of middle age, of stars settling into long, stable existence. The Orion Nebula tells the story of birth, of chaos coalescing into order. Andromeda tells the story of scale, of the vast gulf between galaxies. Globular clusters tell the story of age, of survival across billions of years. Together, they paint a picture of a universe that's dynamic, creative, and ancient. A universe where nothing is permanent, but everything is connected. Where stars are born, live and die, recycling their material into new generations. Where galaxies collide and merge. Where even the largest structures are temporary on cosmic timescales. And yet, for now, everything is in place. The patterns are there, the clusters are bound, the nebulae are glowing, the galaxies are wheeling through space. And you can see it all, or at least glimpses of it, just by looking up. Tonight, if you can, take a moment to seek out one of these deep sky objects. Find the Pleiades, look for Andromeda, gaze at the Orion Nebula. Even if you only see a faint smudge, you'll know what you're looking at. You'll know that fuzzy patch is a galaxy, an entire universe of stars, or a nebula, a cloud of gas light years across, or a cluster, hundreds of stars bound together. And that knowledge transforms the experience. You're not just seeing light, you're seeing structure, you're seeing evidence of gravity, of nuclear fusion, of the processes that shape the cosmos. Let that knowledge settle into your mind as you drift towards sleep. The universe is vast and complex, but it is also comprehensible. Humans have figured out what these objects are. We've measured their distances, understood their nature, and that's a comfort. The universe is not random chaos. It's ordered, beautiful, and you're part of it. Rest peacefully beneath the sky, knowing that above you, in the darkness, entire galaxies and nebulae and star clusters shine silently, patiently, waiting for someone to look up and notice. When you look at the night sky, you're seeing stars, planets, the moon, maybe a comet or two. But here's a secret. Most of the universe is invisible, not because it's too faint to see, not because it's hidden behind dust, but because it doesn't emit light. Most of the universe is made of stuff we can't detect directly. We only know it's there because of its gravitational effects. Astronomers call this invisible material dark matter and dark energy. And together, they make up about 95% of the universe. Everything we can see, all the stars and galaxies and nebulae, all the light in the cosmos, is only about 5% of what's out there. The universe is mostly dark. Dark matter was first proposed in the 1930s when astronomer Fritz Zwicky noticed something odd. He was studying galaxy clusters, groups of galaxies bound together by gravity. When he calculated how much mass the galaxies should have based on the light they emitted, he found they didn't have nearly enough mass to hold the cluster together. The galaxies were moving too fast. They should have flown apart, but they didn't. Something invisible was holding them together. Zwicky called it dark matter, and the name stuck. Since then, evidence for dark matter has piled up. Galaxies rotate faster than they should based on the mass of their visible stars. Something invisible must be providing extra gravity to hold them together. When astronomers map the distribution of matter in the universe using gravitational lensing, where massive objects bend light from objects behind them, they find that most of the mass is not where the galaxies are. It's spread out in vast halos surrounding and connecting galaxies. This invisible mass doesn't interact with light. It doesn't emit, absorb, or reflect electromagnetic radiation. It only interacts through gravity, so we can't see it. But it's there. Lots of it. About 5 times as much dark matter as normal matter in the universe. What is dark matter? Nobody knows. It's one of the biggest mysteries in physics. It might be particles we haven't discovered yet. Weakly interacting massive particles, or WIMPs, are a leading candidate. Or maybe it's primordial black holes, formed in the early universe, or something else entirely. Physicists are building detectors deep underground, shielded from cosmic rays, hoping to catch a dark matter particle interacting with normal matter. So far, nothing definitive. But the search continues. Dark matter is out there. We just can't see it or touch it. It's a ghost. But a very important ghost. Without dark matter, galaxies wouldn't have formed. Stars wouldn't exist. We wouldn't be here. Dark matter is essential to the structure of the universe. Then there's dark energy, which is even stranger. Dark energy was discovered in the late 1990s when astronomers were studying distant supernovae, trying to measure the expansion rate of the universe. They expected to find that the expansion was slowing down due to gravity pulling everything back together. Instead, they found the opposite. The expansion is speeding up. Galaxies are moving away from each other faster and faster. Something is pushing them apart. Something with a repulsive force. They called it dark energy. Dark energy makes up about 70% of the universe. It's everywhere, filling all of space, and it's causing the universe to expand at an accelerating rate. What is it? Nobody knows. It might be a property of space itself, a sort of intrinsic energy that space has. Einstein's equations allow for such a thing, called the cosmological constant. Or it might be a dynamic field changing over time called quintessence. Or it might be something else entirely. Dark energy is one of the deepest mysteries in science. The combination of dark matter and dark energy paints a strange picture of the universe. Most of it is invisible. Most of it is unknown. We're like people in a dark room, feeling around, trying to understand the shape of things by touch alone. We can feel the effects of dark matter through gravity. We can measure the effects of dark energy through the accelerating expansion. But we can't see either of them. They're hidden, and that's unsettling. It means our understanding of the universe is incomplete. There's so much we don't know, so much mystery still out there. But maybe that's okay. Maybe it's even comforting. The universe still has secrets. We haven't figured everything out. There's still wonder, still discovery waiting. And the fact that 95% of the universe is invisible reminds us to be humble. We can see stars and galaxies. We can measure their light, calculate their distances, understand their life cycles. But the universe is bigger than that. There are layers we don't understand, forces we can't see, and that's beautiful in its own way. It means the universe is not fully knowable. There will always be more to learn, always more to wonder about. As you close your eyes tonight, think about the invisible universe. Think about the dark matter holding galaxies together. Think about the dark energy pushing galaxies apart. Think about all the things we don't see, can't see, but know are there. It's a reminder that reality is deeper than appearances, that there's more to the world than what meets the eye, and that mystery is not something to fear. It's something to embrace, something to marvel at. The universe is vast and strange and mostly invisible, but it's also home. It's where you are, and that's enough. Rest peacefully knowing that even the things we can't see are part of the same cosmos that holds you, that guides you, that keeps you safe. The universe is mostly dark, but that darkness is not empty. It's full of mystery, full of possibility, full of wonder, and you're part of it all. When you look at the stars, you're not just seeing light, you're seeing time. Every photon that reaches your eye is a messenger from the past. And because the universe is so vast, those messages come from different eras. Proxima Centauri shows you 4 years ago. Betelgeuse shows you about 500 years ago. Galaxies show you millions or billions of years ago. The night sky is a time machine, a window into history. And that's one of its most profound secrets. The universe is about 13.8 billion years old. We know this from multiple lines of evidence. The expansion rate of the universe measured through distant galaxies, the cosmic microwave background, the faint glow left over from the Big Bang, the ages of the oldest stars calculated from their composition and brightness. All these measurements converge on the same number, 13.8 billion years, give or take a few hundred million. That's the age of everything: space, time, matter, energy. It all began at the Big Bang, a moment of unimaginable density and temperature when all of existence was compressed into a point smaller than an atom. Then it expanded, and it's been expanding ever since. In the first moments after the Big Bang, the universe was a hot, dense soup of fundamental particles. Quarks, electrons, photons, no atoms yet, just energy. As the universe expanded, it cooled. After a few minutes, protons and neutrons could form. After a few 100,000 years, the universe cooled enough for electrons to bind with protons and form hydrogen atoms. This was the moment of recombination, and it marked the moment when light could travel freely through space. Before this, photons were constantly scattered by free electrons. The universe was opaque, like being inside a cloud. But after recombination, the universe became transparent. Light could travel unhindered, and that light is still travelling today. It's the cosmic microwave background, a faint glow visible in all directions, the oldest light in the universe. Telescopes have mapped it in exquisite detail, and it tells the story of the universe when it was only 380,000 years old. After recombination, the universe entered a dark age. No stars yet, just hydrogen and helium drifting through space. But gravity was at work. Tiny density fluctuations, seeds planted during the Big Bang began to grow. Matter clumped together, pulled by gravity into denser regions. Dark matter helped. Its gravity amplified the clumping. Eventually, about 100 million years after the Big Bang, the first stars ignited. Massive, hot stars, burning through their fuel quickly and exploding as supernovae. These first stars created the first heavy elements: carbon, oxygen, iron, the building blocks of planets and life. When these stars died, they scattered their elements into space, enriching the gas clouds that would form the next generation of stars. This cycle continued. Stars formed, lived, died, and enriched the universe. Galaxies assembled from smaller clumps. Galaxy clusters formed from gravitational attraction. Structure emerged from chaos. Our Sun formed about 4.6 billion years ago from a cloud of gas and dust enriched by previous generations of stars. It's a third-generation star at least, maybe fourth. The atoms in your body were forged in the cores of stars that died before the Sun was born. You're made of recycled stardust. The calcium in your bones was made in a supernova. The iron in your blood was forged in the heart of a dying star. The oxygen you breathe was created by massive stars and released when they exploded. You're not separate from the cosmos. You're part of it, literally. Your atoms have been part of stars, part of gas clouds, part of asteroids and comets, part of the early Earth, part of ancient life, part of dinosaurs, part of oceans, and now part of you. And after you die, those atoms will continue. They'll become part of the Earth, part of other organisms, maybe eventually part of new. Stars if Earth is destroyed when the Sun dies. The atoms are eternal, only their arrangement changes. The night sky you see tonight is a snapshot of cosmic history. The nearest stars show you the recent past. Distant galaxies show you the ancient past. And in between, at every distance, you're seeing different epochs of the universe. If you could somehow stop time and map every photon reaching Earth at this moment, you'd be creating a three-dimensional map of cosmic history. A map where distance and time are the same thing. Look farther, see older. The most distant galaxies ever observed are so far away that their light has been travelling for more than 13 billion years. We're seeing them as they were when the universe was less than 1 billion years old. Those galaxies are long gone by now. They've merged with others, evolved, changed. But their ancient light is just now arriving. We're seeing ghosts, echoes of the past. And that's what astronomy is. It's history, it's archaeology, it's detective work, piecing together the story of the universe from the light that reaches us. This perspective changes how you see the night sky. It's not just pretty lights. It's a library, a record, an archive stretching back billions of years. Every star, every galaxy, every nebula is a chapter in the story of cosmic evolution. And you're reading that story every time you look up. You're engaging with history on the grandest scale imaginable. And here's the beautiful part. The universe is still writing new chapters. Stars are still forming. Galaxies are still colliding. Planets are still being born. The story continues. And someday, billions of years from now, beings on another planet will look up at their night sky and see our galaxy, our stars, as they were in this era. They'll see photons that left the Milky Way tonight. They'll see our sun, if they have powerful enough telescopes, as it was when you were alive. You'll be part of their ancient history, a speck in their deep past, and in that way, you're immortalized. Your era, your time, the light from your world will travel forever, carrying a message into the future. The universe is patient. It operates on timescales that dwarf human lifetimes. Stars live for millions or billions of years. Galaxies evolve over tens of billions. The cosmic microwave background has been glowing for over 13 billion years, and dark energy suggests the universe will continue expanding forever, eventually becoming cold, dark, and empty as stars burn out and galaxies drift apart. but that's trillions of years in the future. For now, for billions of years to come, the universe is alive. Stars are shining, galaxies are colliding, nebulae are glowing, and you're here in this brief moment of cosmic history able to witness it all. What a gift. Tonight, as you settle into sleep, think about time. Think about how the light touching your eyes left distant stars centuries or millennia ago. Think about how you're connected to the Big Bang, to the first stars, to every generation of cosmic evolution. Think about how you're made of atoms that have existed since the early universe, atoms that have been part of countless structures and will continue long after you're gone. You're temporary, but you're part of something eternal. You're a fleeting arrangement of ancient matter, given life for a brief moment, able to look up and understand. That's extraordinary. That's beautiful. And that's enough. Rest peacefully, knowing that time flows around you, that the universe stretches out in all directions through space and time, and that you're connected to all of it. The stars are watching over you, ancient and patient, and they'll be there tomorrow, and always. As we come to the end of our journey through the night sky, it's time to rest, to let all these images and ideas settle gently into your mind like snow falling on a quiet field. The night sky is not something you master or conquer. It's something you experience, something you feel, something that reminds you of your place in the universe. Small but connected, temporary but meaningful, alone but part of something vast and beautiful. Think about everything we've explored tonight. We've journeyed across impossible distances, riding along with ancient photons that have travelled for years, decades, centuries, even millennia to reach your eyes. We've traced the patterns our ancestors drew in the stars, connecting myths and science, stories and facts past and present. We've watched the moon pull on our oceans, creating the rhythmic dance of tides that has shaped life on Earth. We've followed the wandering planets through their stately orbits, understanding that what seems like random motion is actually perfect celestial mechanics. We've stood within our home galaxy, the Milky Way, and understood our suburban position in its spiral arms. We've witnessed the brief fireworks of meteors, cosmic dust burning bright for just a moment. We've marvelled at the auroras, the visible manifestation of invisible forces, solar wind meeting magnetic field in a dance of light. We've peered into deep space, seeing star clusters and nebulae and distant galaxies. We've contemplated the invisible universe, the dark matter and dark energy that fill most of existence, and we've travelled through time itself, understanding that looking outward is looking backward, that the universe is a time machine built from light and distance. The secrets of the night sky are not complicated once you strip away the mathematics and jargon. They're simple, profound truths. Light takes time to travel, so when you look up, you look back in time. Stars are suns, burning with the same nuclear fire that powers our own sun. Planets wander through the sky, worlds you could visit if you had the means. The moon pulls on Earth, creating tides, stabilizing our climate. Constellations are patterns humans have found in the chaos, stories projected onto the cosmos. The Milky Way is home, a spiral of stars containing everything you've ever known. Meteors are cosmic dust burning up in our atmosphere, brief streaks of light that remind us we're moving through space. Auroras are the result of the solar wind colliding with Earth's magnetic field, painting the sky in colours that seem impossible. Deep sky objects are windows into the broader universe, proof that space is filled with structure and beauty. Dark matter and dark energy are mysteries, reminders that we don't know everything, that the universe still has secrets, and time flows through it all, connecting past and future, creation and dissolution, life and death. Everything is connected, everything is in motion, everything is beautiful. These secrets are relaxing because they're bigger than your problems, they're older than your worries. The stars don't care about your deadlines, the galaxies don't notice your mistakes. The universe is vast and ancient, and it puts everything into perspective. Your troubles are real, but they're also small, temporary. They'll pass. The stars will still be there. The moon will still rise. The planets will still wander. And that's comforting. It means you can let go. You can stop holding so tightly. You can relax. Because the universe will continue whether you worry or not. And it's beautiful either way. Stargazing is an act of meditation. When you lie on your back and look up at the stars, your mind quiets. Thoughts drift away. Worries fade. You're present. Just you and the sky. No past, no future, just now. The stars blink down at you from impossible distances, and you blink back, and in that moment you're connected. You're part of the cosmos, a conscious piece of the universe looking back at itself. And that's enough. You don't have to do anything. You don't have to achieve anything. You don't have to solve problems or make plans or worry about tomorrow. You just have to be. Just exist. Just breathe. And the stars will be there, witnessing your existence, holding space for you in the grand scheme of things. They've witnessed billions of years of cosmic history, and now they're witnessing you, this moment, your life. That's profound. That's meaningful. That's all you need. So tonight, as you drift off to sleep, carry the stars with you. Imagine them shining above, even though you can't see them through the ceiling. Imagine their ancient light travelling through space, arriving at Earth, touching the atmosphere, filtering through to the ground. Imagine the moon pulling gently on the oceans, the tides rising and falling. Imagine the planets in their orbits, moving at their own pace, patient and predictable. Imagine the Milky Way stretching across the sky, a river of light. Imagine meteors streaking through the atmosphere, brief flashes of cosmic fireworks. Imagine auroras dancing over the poles, silent curtains of light. Imagine nebulae glowing in the depths of space, new stars being born. Imagine galaxies wheeling through. The void, vast and ancient. Imagine dark matter holding it all together, invisible but essential. Imagine dark energy pushing the universe apart, causing the expansion to accelerate. And imagine time flowing through it all, connecting everything, past and present and future. You're part of this. You're connected to the stars through the atoms in your body. You're connected to the moon through its gravitational influence on your world. You're connected to the sun through the light and warmth it provides. You're connected to the galaxies through the fact that you exist in the same universe, subject to the same laws of physics. You're not separate. You're not alone. You're part of the cosmic family. And that family is vast, ancient and beautiful. As you close your eyes, let the night sky be your lullaby. Let the slow wheeling of the stars above remind you that time passes gently. Let the patient light from distant suns remind you that some things are eternal. Let the cycles of the moon remind you that change is natural. Let the wandering planets remind you that motion is part of existence. Let the meteors remind you that even brief flashes of light are beautiful. Let the auroras remind you that invisible forces shape the world. Let the nebulae remind you that creation is ongoing. Let the galaxies remind you that the universe is incomprehensibly vast. Let the dark matter and dark energy remind you that mystery is part of existence. And let the flow of time remind you that everything is connected, that the past shapes the present, and the present shapes the future. You're safe. You're held by the earth, which is held by the sun, which is held by the Milky Way, which is held by the universe itself. Gravity cradles you. Light surrounds you. Time flows through you, and you're exactly where you need to be. Right here. Right now. In this moment. Under these stars. Part of this cosmos. You don't need to be anywhere else. You don't need to be anyone else. You're perfect exactly as you are. Exactly where you are. The universe made you. The stars forged your atoms. The earth nurtured your molecules into life. And now you're here. Conscious. Aware. Able to think and feel and experience. What a gift. What an absolute miracle. Sleep well, dear friend. Dream of stars and galaxies, of light and time, of vastness and connection, and when you wake the stars will still be there, patiently waiting for you to look up again. Until then, rest. The universe is watching over you, and it always will be. Thank you for joining me on this journey through the night sky. If you enjoyed this peaceful exploration, please consider liking the video and subscribing to the channel. It really helps me continue creating these calming journeys for you. And as always, I'd love to hear from you in the comments. Where are you watching from? What's your favourite thing about the night sky? Have you ever seen an aurora or a meteor shower? Share your stories. Until next time, good night.